This episode describes the standard PF ratios method. In episode 1, we offered an introduction on methods for assessment of completeness of fertility data from censuses. This second episode describes the standard PF ratios method using data from one census. If you want more detailed information about the steps to estimate standard PF ratios, please see Annex 1 in this module. This module provides information that will help you understand intuitively the logic behind the standard PF ratios method using data from one census. In episode 3, we will cover the extension of this method using data from two censuses, also called PF ratio for synthetic cohorts method. I'll start this module with a description of the tabulations required. Then I'll cover its assumptions, explain the logic behind the method, and briefly describe it. At the end of the session, I'll show an example for interpretation purposes. I'll close this episode with a discussion of advantages and limitations and a learning assessment. The standard PF ratios method uses data from a single census. In addition to the data on population and mortality, to estimate fertility adjustments, you will need tabulations of number of children ever born alive by 5-year age groups of mother of reproductive age, number of births during the year preceding the census classified by 5-year age groups of mother of reproductive age, and number of women in 5-year age groups. The standard PF ratios method rests on three main assumptions. First, fertility is not changing over time. Second, reporting of the number of children ever born alive, or average party, is essentially accurate among younger women ages 20 to 35, for whom there are typically fewer recall errors and omissions compared to older women. Third, the number of births in a given reference period can be distorted by omission, meaning not reporting a live birth, or by date displacement, meaning the wrong date of birth was provided, but the age pattern of births is not distorted. Remember that the method compares age patterns of two similar measures of fertility. It assumes that age patterns are accurate. Let's review the definitions of two core concepts in the evaluation and adjustment of fertility: parity and lifetime fertility equivalence. Parity refers to the total number of children previously born alive, or the total number of children ever born to a woman. Lifetime fertility equivalents refer to the number of children who would have been born by women experiencing observed fertility rates from the beginning of childbearing at age 15 to age 49. Let's put together the logic behind the method and its assumptions. Remember, the method is based on comparing the age patterns of two similar fertility measures, average parity and lifetime fertility equivalents. If fertility has not changed in the recent past, an assumption of the standard PF ratios method, then fertility rates computed from number of recent births can be accumulated to obtain measures equivalent to average parities. Ideally, parity and lifetime fertility equivalents are similar. But when the number of births reported in a census are incomplete, parity is larger than lifetime fertility equivalents. If the recent births are not completely recorded due to the biases we mentioned in the last episode, these lifetime fertility equivalents will be smaller than the reported average parities, and you will need to estimate an adjustment factor based on the PF ratios and apply it to the number of births to account for the undercounting of births reported in the census. We know, based on empirical observation, that average parity estimates from children ever born alive by age of the mother often exceed the cumulative age-specific fertility rates estimated from births reporting during the prior year in a census. Therefore, reported number of children ever born alive is assumed to better reflect actual fertility levels, particularly for mothers between 20 and 34 years of age. I will show you an example later in this module. The PF ratios method assumes that the difference between average parity and cumulative age-specific fertility rates reflects relative underreporting of births during the prior year, which is the measure we are evaluating and adjusting if necessary to better reflect the level of obstetric risk in maternal mortality or pregnancy-related mortality measures. The PF ratios method produces a set of adjustment factors for age-specific fertility rates based on mothers' age patterns of children ever born. If the number of births in the prior year is underreported, then measures of average parity and age-specific fertility differ, and your PF ratios are likely larger than 1. In this case, the number of births in the year prior should be adjusted based on age patterns of children ever born alive among women 20 to 34 years of age. In the next slides and Annex 1, we show how to estimate and apply this adjustment. It is already included in the PRM Census workbook. You do not need to estimate it by hand, but it is always important to be aware about the logic behind the method. There are 3 main steps for the estimation of PF ratios and adjustment factors. The first step is to estimate average parity, which is the reported number of children ever born alive by the number of women in a specific age group. The second step is to estimate lifetime fertility equivalents. For details on this estimation, please see Annex 1. The third step is to divide age-specific measures of average parity by the corresponding measure of lifetime fertility equivalent. Remember, the workbook estimates these age-specific measures and the ratios for you. You do not need to do any calculations by hand. An age-specific PF ratio results from dividing age-specific average parity by the corresponding age-specific lifetime fertility equivalent. If there is low or no birth underreporting, PF ratios by ages of mother 20 to 24, 25 to 29, and 30 to 34 should be similar and close to 1. If there is birth underreporting, PF ratios by age of mother 20 to 24, 25 to 29, and 30 to 34 should be similar and larger than 1. In this figure, we show the age pattern of average parity PI in the solid line and lifetime fertility equivalents FI in the dotted line. Please note that as age increases, the distance between these two measures also increases. Remember that we usually observe measures for ages 20 to 34 only because the recall error of the number of children ever born alive is likely to be lower for younger than for older women. In this figure, we show the corresponding PF ratios. Although values of the PF ratios increase with age, note that the PF ratio for age of mother 20 to 24 and 25 to 29 are closer and more consistent than the PF ratios for age of mother between 25 to 29 and 30 to 34. In this case, we should average the PF ratios by age groups of mother 20 to 24 and 25 to 29 and estimate the adjustment factor. The PF ratios in this example increase with age, showing that the difference between average parity and lifetime fertility equivalents increases with age when fertility change over time is not considered. The selection of PF ratios by age of mother depend on their consistency. The adjustment factor K can be estimated as the PF ratio for ages of mother 20 to 24 or the average of the PF ratios for ages of mother 20 to 24 and 25 to 29, or the average of the PF ratio for ages of mother 20 to 24, 25 to 29, and 30 to 34. This figure shows the difference in adjustments using different PF ratios. Unadjusted or reported age-specific fertility rates are shown in dark blue. Age-specific fertility rates adjusted with PF ratio for ages of mother 20 to 24 or PF2 over F2 are in orange. Age-specific fertility rates adjusted with PF ratio for ages of mother 25 to 29 or P3 over F3 are in gray. Age-specific fertility rates adjusted with PF ratio for ages of mother 30 to 34 or P4 over F4 are in yellow, and age-specific fertility rates adjusted with the average of all PF ratios are in light blue. To close this episode, let's review the advantages and limitations of the standard PF ratios method. An advantage of the method is that it requires a small amount of information from a single census. For example, tabulations of children ever born by age of women, children born in the last 12 months by age of women, and number of women in reproductive age by 5-year age groups. In addition, you could use fertility data from a demographic and health survey or any other high-quality survey that includes these variables. A limitation of the standard PF ratio method is that it assumes that fertility has not changed in the recent past. We solve this limitation in the next episode with the PF ratios method for synthetic cohorts. Be aware that if fertility has been falling and the average age at first birth has been increasing, then the application of the standard PF ratios method might result in overestimation of fertility. Please answer true or false to the following two statements. First statement. One of the principles of the PF ratios method is that reported children ever born are assumed to poorly reflect actual fertility levels, particularly for mothers between 20 and 34 years of age. Second statement. One of the assumptions behind the PF ratios method is that the level and age pattern of fertility have not changed in the last 15 to 20 years previous to a census or survey. Here are the answers for the previous two questions. First statement, one of the principles of the PF ratios method is that reported children ever born are assumed to poorly reflect actual fertility levels, particularly for mothers between 20 and 34 years of age. It is false. Reported number of children ever born alive for women between 20 and 34 years of age are considered accurate and therefore reflect actual fertility levels. Second statement. One of the assumptions behind the standard PF ratios method is that the level and age pattern of fertility have not changed in the last 15 to 20 years prior to the census or survey. It is true. This is one of the assumptions behind the method, and since this assumption is often violated, the PF ratios method for synthetic cohorts were developed.